Hello and welcome to Unit 7, Part 5. My name is Mr. Bell, and today we're going to talk about factoring by grouping. And then once we learn that concept, it's going to help us when factoring trinomials. This slide says to factor by grouping, and we have 2p to the third plus 5p to the second plus 6p plus 15. Well, before we start actually digging into this problem, let's talk about what the word factoring means, just as kind of a refresher. Remember, factoring is when you break something down into its multiples. An example I'll do down here in red is the number 10. Well, 10 can be broken down, this is just one of the many examples, can be broken down into 2 times 5. The 2 and the 5 are factors of 10. One more example in red. Remember, in earlier lessons, we did something called the distributive property. Let's just say 2 times the quantity of x plus 3. And we would take this 2, since it's being multiplied by that parentheses, and we would distribute that 2 to both terms on the inside, giving you a result of 2x plus 6. Well, that is the distributive property in multiplication. And recall that what we can do is we can go from this 2x plus 6 as our product, factor it by pulling out the greatest common factor, which in this case, out of 2x and 6 is a 2. And when you factor out, you actually divide out that 2, leaving you with an x, and then 6 divided by 2 is 3, which was our original question. Now let's move forward to our actual question that has 4 terms. What we're going to do is factor by grouping. A good practice is to group the first 2 terms together and then group the second 2 terms together. But really what you're doing is you're grouping terms that have something that can be factored out. Let's dig into this. 2p to the third plus 5p to the second. Well, of those 2 terms, they both have a p to the second power. So I can pull out a p to the second power. Don't forget, in factoring, you have to write what's left on the inside once you've pulled out or factored out that p squared. In this case, we're left with a 2 and a p. And then on the other term, we're left with just a plus 5 because the p squares canceled. And on the first term, 2 of the p's canceled, leaving you with just 1 remaining. So that's where this 2p is left. Now moving over to the right grouping, 6p plus 15. Well, what's the greatest common factor of 6p and 15? I believe it is a 3. So you can factor out a positive 3. Now if you factor out or divide out a positive 3, what's left on the inside? Well, from 6p, if you divide out a 3, you're left with 2p. 15 factored out a 3 or divided by 3 gives you a plus 5. This is the same thing as the distributive property, but backwards. 3 times 2p would give you the 6p, and 3 times 5 would give you a 15. We just pulled out the greatest common factor. That's the idea of factoring. Now this is a little difficult to notice at first, but eventually you'll see what I have now as 2 separate terms. There is this term, which is p squared times 2p plus 5, plus the second term, 3 times 2p plus 5. Both of these terms have a common factor. The 2p plus 5 is the same in both terms. We can factor that out. So we're going to pull out that 2p plus 5 from both terms, just like we did the p squared or the 3 in the previous example. So we pulled out this 2p plus 5. Since that factor has been divided out, what's remaining? Well, we're left with this p squared and this plus 3. I know that's a little confusing. You can go back and rewatch this section of the video, but we grouped the 2 terms together, we factored out a GCF, and then we factored out another GCF to get our answer, which is these 2 factors would multiply to give us our original question. Now let's use this factor by grouping concept to factor trinomials on the next slide. Now let's factor this trinomial because there are 3 terms. Let's factor this trinomial, and we're going to use the concept of factor by grouping from the previous slide. Now, this method that we're fixing to use to factor this is often called the AC method. And I'll show you why it's called the AC method in just a second. Down here at the bottom, remember the standard form of a quadratic is ax squared plus bx plus c is equal to 0. Well, that's where I'm going to get my a and my c from, and in a minute you'll see I use b as well. They come from the coefficients or the constant term of your quadratic. In the AC method, what you're going to do is multiply your a term times your c term. In this case, it's 3 times negative 5, which is negative 15. You need to find the factors of a times c that add up to be your b term, and our b term was a negative 2. So now you've got to think of two very specific factors, multiples, that multiply to give you negative 15. They also have to sum or combine to be a negative 2. You probably notice that it's going to be some combination of 3 and 5, but you got to figure out which term gets the negative. Well, in order to combine to get a negative 2, the negative sign must go with the 5. 3 times negative 5 is negative 15. 3 plus negative 5 is negative 2. So now that I have found these two factors using the AC method, I'm going to rewrite my original trinomial as 3p squared, break the negative 2p down into 3p minus 5p, bring down the minus 5. Okay, all I've done is rewrote that negative 2p term as 3p minus 5p. Those two terms would combine to give you that anyway. So mathematically this is okay to do. The reason I've done this is now, if you paid attention on the first slide, I have a 4-termed polynomial which we can factor by grouping. So let's do that real quick. We'll group the first set and then we'll group the second set together. And let's see what we can factor out of my first grouping of parentheses. They have a 3 and a p in common. So let's pull out a 3p. Don't forget to write what's left. If you factor out or you divide out a 3p, I'm left with just 1p, and then 3p divided by 3p is 1. Let's move on to the right grouping. To factor out from negative 5p minus 5, I can pull out a negative 5 from both of them. If I do that, let's see what's left. So I divide out a negative 5 from both of my terms. Well, that just leaves me with a p. Negative 5 divided by negative 5 is a positive 1. You may also notice from the first slide, both of these two terms have a factor of p plus 1. Let's pull out that p plus 1, and then you write what's left, which is 3p minus 5. That is factoring using the AC method and then factoring by grouping. Let's do one more example. This question says 2n squared plus 3n minus 9. This is a trinomial where we've been asked to factor it in this lesson. First, look for a greatest common factor. There's nothing in all three terms that I can factor out. So now I'm going to move to the AC method. I'm going to take my a times c, which is 2 times negative 9 to give me a negative 18. And then my b term was a positive 3. I need to find what multiplies to be negative 18 but adds to be a positive 3. So I know it's going to be some combination of 6 and 3. And let's figure out which one gets the negative. In this case, it's going to be the 3, because 6 times negative 3 would give you negative 18. 6 plus negative 3 gives you that positive 3. So I found my two very specific factors that I want. I'm going to break down my middle term here into those factors, which would be 6n and a minus 3n. That would combine to give me the positive 3n. And then just bring down the 2n squared and the minus 9. Now recall that I have a 4-termed polynomial like my first slide of this video presentation, and I'm going to factor this by grouping. Group the first two, group the second two together, and let's pull out the greatest common factor of each. On this left grouping, they have a 2 and an n in common. I can pull out 2n or divide out 2n from both terms, leaving me with just 1n plus 3. And then on the right grouping, I can factor out a negative 3. And if I divide out a negative 3 from both of those terms, I'm left with just an n and a plus 3. What you'll start looking for is, once you have found that first parentheses of what's left after you factor it out, you should find that same one on the right set. If not, you might want to double check that you actually pulled out the greatest common factor. All right, one last step. Factor out that n plus 3 that these both have in common, and that leaves you with 2n minus 3. These are the factors that if we did FOIL or the distributive property or multiplied these two binomials, it would give us our original question. All right, thanks for watching. Hope this helps.